Perfect. So, hi, thanks for having us. So today we're presenting a project that we did at National Bank, which we call Hitting Two Birds with One Stone, using a dialog system model for automated email answering. Trying to change the slide. So I'll start with what motivated us to do this project. So like pretty much all companies that offer customer services, we are faced with the two following challenges when answering clients' questions. That is either by phone, by emails, or by chat. So the first one is that it is costly and time consuming, and that there can be a long waiting time, which can cause client to be dissatisfied. Therefore, a few years ago, we created a dialog system that aims to answer questions without any human intervention and without any waiting time. And that's what we can see on the right side here. It's a screenshot of the dialog system that is currently on our website, as well as our online banking platform. However, clients still prefer to send us, well, some clients prefer to send us email rather than chat with us. And this is unlikely to change, as it is estimated that in 2025, there will be about 376 billion emails sent to or from businesses. So this includes our banks, other banks, and all businesses. So it is important to find a way to reduce the workload of our agents that answer emails. And so what we decided to do is to reuse a solution that already exists, which is our dialog system, to try to answer emails. So the goal here is not to find the best way possible to answer emails, but rather to see if we can find a low-cost solution that can be quickly implemented by reusing something that already exists and that works well, which is our dialog system. So we did a research on what was done before. What we found is that most research date back to more than 10 years ago when for the subject of automated email answering. A survey made in 2016 by Snyder stated that there are three main approaches to automatically answer emails. And the first one is text pattern matching, which is basically creating rules for each category. There's also statistical text similarity calculation, which is pretty self-explanatory. And the third one is text categorization by machine learning, which is what we do. And so I'll go further on this one. So there are two examples of research that use that method below. So the first one is Bosman et al. In 2000 that compared SVM, naive Bayes, Cannon, and Ripper to try to categorize emails into 47 categories. So the training data were emails, and the target audience was agents. What this means is that the agents were receiving the answer from the predicted category, and then they will they chose whether they wanted to send that that answer to the client, or they wanted to modify it before sending it, or just ignoring it and then writing their own answers. The other research is Scheffer in 2004, which is pretty similar. They compared SVM and naive Bayes to categorize emails into 9 categories, and the training data were emails, and the target audience was agents as well. So our solution is a bit different. We have way more categories, about 237, which are based on our frequently asked questions. We use a neural network, and the training data is chat messages. And this is because, like I said, we want to create a low-cost solution. So we want to reuse something that already exists while doing the minimal changes to it. So we decided to keep the same training data and see if this can still be used to answer emails and reduce the workload of our agents. And the target audience is clients, and I'll show you how in just a second. So our solution, like I mentioned, we want to reuse our dialog system model to answer emails sent from our online banking platform. So we can see the online banking platform on the left, and there's a contact us page where client can click on send an email, which open the window on the right. So before we implemented our solution, clients could write their question here, and instead of clicking on continue, they would click on send, and the email will be sent right away. Now what we do is, if the model has a high enough confidence, instead of sending the email right away, they will receive an answer. And then the client himself can choose whether or not he still wants to send his email, or if the automated answer to answer these questions, and then the email won't be sent, which will reduce the workload of our agents. So before we talk to you about how we adapted our model to answer emails, I want to give some characteristic of our dialog system model. So it is a neural network classification model that uses Rasa Diet classifier, which is open source. There are, like I mentioned, 237 categories, which each have between 3 to 200 training data. So there's a huge gap between 3 and 200. The reason behind that is the sources of the training data. So mostly it is, well, we started with artificial data to kickstart our model. So basically we created ourselves questions for each of the category that looked like what we thought clients would write to our dialog system. And then once the model was in production, we added real data from real interactions with our clients from the dialog system. So that's why some categories have way more training data, because it is way more popular. It is more frequently asked by our clients. And the type of training data is chat-like questions. And this is important because it can be quite different from emails. So it is usually shorter, non-formal, and there are no greetings such as best regards and everything. So the goal was to see if even with those differences, we could still try to answer some of the emails.
So starting from that model Florence just described, we were able to create quickly an email answering solution. The first step was to remove all categories that were called chit chats. So those are specifically related to the conversational flow. An example will be the greeting category of our dialog system. As we expect that no email will contain only a greeting, we can be confident in the fact that we take out that type of category. We also removed our multi-stage clarification mechanism. This is a series of interaction that allows to clarify the client's need whenever the model's confidence in its prediction isn't low high enough. And then we have a simpler model. To ensure good user experience, we need to configure a threshold. So that threshold is a confidence level in the model's prediction, below which we do not return an answer to the email. It is rather sent straight away to our team of representatives. So to configure such a threshold, we use a test set of 1,005 French emails that were received on our online banking platform. For each one of them, we asked ourselves if the email could be categorized into one of our 237 categories. If yes, it was considered in scope, as it was the case for 456 of them. And if it could not be associated with one of the categories, meaning that there's no way our model could give a good answer to that email, it was categorized in the out of scope category. And then for every in-scope email, we associated it with the right category. We use that data set to test our model and observe its behavior for different values of the threshold. That behavior was summarized by 4 metrics that were each plotted against different values of the threshold, as you can see on the right. The first one we'll look at is the in-scope answered. It is the ratio of in-scope emails, so emails that can be categorized into one of our model's categories, for which the model's confidence in its prediction is above the threshold. So you can see that for a threshold of 0%, all in-scope email get answers, and that this ratio decreases as we increase the threshold. The second metric we looked at, you can see it in green on the graph, it's the in-scope accuracy. It is the ratio of in-scope answered that get good answers. So for that one, without threshold, we have an accuracy of 45% for in-scope emails. But then that accuracy increases as we increase the threshold. Then we also looked at the out-of-scope answered. So it is a proportion of the 549 emails that were out of scope that are still classified with a confidence higher than the threshold. In an ideal world, that value will be of 0. But then as you can see, all out of scope emails get an answer for a threshold of 0%, but less of them get answers as we increase the threshold. And finally, the last metric we looked at is the automated emails. It is our estimation of the ratio of emails that we receive that get good answers. It is estimated by the multiplication of the in-scope ratio, the in-scope answered, and the in-scope accuracy. So both in-scope answered and in-scope accuracy are shown on this graph and explained on this slide. But then the in-scope ratio, it is the ratio of the in-scope email on all the email we receive. So it is 45%, as you could calculate with the data I showed you earlier. So keeping in mind that we want to optimize those 4 metrics, we first considered a threshold of 63%, which represents the meeting point of the in-scope answered and the in-scope accuracy lines, the black and the green ones. For such a value, we have an out-of-scope answer of 37%, meaning that more than a third of the incoming emails that should not, well, cannot be categorized into either one of our categories get automatic answers. As this does not allow us to give the user experience we aim at, we chose to look at another value for the threshold. So if you look at the red line, you can see that the automated emails slowly decreases from a threshold of 0% to one of 80%. But then at 80, we see that there's a drop. So in order to optimize the quality of the answer we give and the number of answer we give, we chose that point as a threshold. So now that we have a threshold of 80% to give an automatic answer, and that we have removed every conversational flow features, we have a dialog, well, an email answering model that is ready to be put into production. Florence, could you go to the next slide? So yeah, so it's been online since the end of November 2021. Its implementation was low cost and quick as we use a system that already existed. To this day, it allows us to answer more than 10% of the email that we get on our online banking platform, and it required no changes in the customer service processes. And the most important part is that now we have an improved user experience as we give quick answers to simple questions. So if any one of you have any question about our solution, Florence and I will be happy to answer them.
Excellent work, Claudie and Florence. Much appreciated. As I said, I'm educating myself and I'm learning more from your presentations than when I read the short papers. So I really appreciate presenting for us. And has this been put in production?
Yes, it has been in November 2021. So if you're a client of National Bank, you can use that service on your online banking platform.
Right. So what was the feedback from the users, or have you received any feedback, or how does it perform, the application?
Maybe I can take that one. So we didn't do any surveys yet with the users. What we do have is the metric that you can see on the screen, which is the 10% of emails automatically answer. So basically what we do know is that those 10% didn't send the email. So they did say that the answer they received was correct. So.
Okay, right. Okay. And yeah, I guess do you see any room for improvement for speeding the computation?
Definitely, yeah. We have a few ideas in mind.
Okay.
We didn't implement any of them yet, but the thing we could try to add some training data to resemble emails, for example. We also try to see if we could remove greetings from emails, because those can basically be found on emails, and see if the model could interpret them easier without those basic marks at the beginning and at the end of emails and stuff like that. But we didn't really tried anything yet. We're just having ideas.
Right. Yeah, that's excellent. Good luck, and yeah, happy to hear more about the enhancements of the model. Thank you.
I think I see another question. I'm not sure.
Sorry, go ahead. Any question in the chat?
Yeah, Ilujo, Leticia.
Okay. Please go ahead, Ilujo.
Yeah, this is a really interesting work.
Thank you.
I just have a question. Why do you think not many people have worked on this very useful, I mean, the answer to the problem is very useful in the last several years? You mentioned that you didn't find much work.
Well,
what people neglected this problem?
What Snyder's mentioned is that basically the dialog system took part of it, and now the automated email answering is considered a solved problem, which isn't really the case. But I think some models can be created directly to answer emails, and they work fine, but not entirely fine. And I think most of the recent research on NLP focuses on dialog system instead.
Mm-hmm. Okay. So I like it. Very good work.
Thank you.
Thank you.